So today's starter is this. We have 16 volts, and we have a resistor here of 8 ohms and a resistor here of 2 ohms. And what you need to do is fill in this chart. So let's do that, and then show your work. You will need to show your work. This is very similar to the problems that you're going to see later on. So anyway, so let's just show that this is given. This is fine. Let's solve. Okay, and well, let's do a voltage first. R1 and R2 are in parallel. Therefore, they have the same voltage drop. So if I give this problem like this to you on a test, if it's a FRQ, you need to justify why you're saying that the voltage drop is the same. The voltage drop is going to be the same for both of these. And here we're going to go from 16 volts to 0 volts, from 16 volts to 0 volts. So that's a change in voltage of negative 16 volts. I'm just going to put 16 volts. I'll know what you mean. It's a resistor. It's a voltage drop if you're going with the current. And so we'll just say that it's 16 volts for both. Now, to get credit for this, you need to say this. Is that understood? In order to get credit for having the right answer, you need to tell me why. They're in parallel. So therefore, they have the same voltage drop. And if you go through this loop, there's a 16 volt gain. Therefore, there has to be a 16 volt loss. If voltage man goes in this loop, 16 volt gain, has to be a 16 volt loss to get back to 0. Because everything down here is at 0 volts. Everything up here is at 16 volts. So to go from, you have to drop by 16, you have to drop by 16 volts. Okay? All right. Now, let's figure out the currents. We know that V equals IR. So let's solve for I1. I1 is equal to V1 over R1. That's 16 volts over R1, which is 8 ohms. 16 divided by 8 is 2. And so an ohm is a volt per amp, so the volts will cancel, leaving amps as your answer. So I1 is equal to 2 amps. And then R2 will do the same thing. Equals V2, which is 16 volts, over R2, 2 ohms. And that's going to be 16 divided by 2 is 8. So it's going to be 8 amps. Which means that how many amps is going through the battery? How many amps do you think will be going through the battery? I didn't ask that. Maybe I should. Well, if I've got 8 amps going through here, and I've got 2 amps going through here, well, I better be pushing out how many amps total? 10 amps. Okay, because as the flowing charge reaches this branch or this fork in the road, it's also called a junction. 2 of the amps will go this way, 8 of the amps will go this way, so you had to have 10 amps going into the junction. Okay? Hopefully that makes sense. Oh, let's put the answer in the blank here. Now, power equals, well, what do I know? I know the resistance, and I know the current. I know the voltage drop. I know, it doesn't matter which one you use. I'll use I times V. It's a little bit easier. So this is P1 equals I1 V1. I1 is 2 amps. V1 is 16 volts. 2 times 16 is 32. And a volt times an amp is a watt. 32 watts. and then through R2. Well, here we have 8 amps. And therefore, we still have 16 volts. And 8 times 16, let's say 8 times 6 is 48. 4, 8, 12, 128 watts. Is that right? Hold on a second. Let's see, 6, 48, 12. Does this make... Oh, yeah, it does. It does make sense. And think about this. How much total energy is coming out of this circuit per second? Well, this is putting out 32. This is what's putting out 128. So that's a total of 160 watts. Well, since it's putting out 10 amps, 16 volts times 10 amps is 160 watts. So that's a good way to check your work. This is putting 160 watts into the circuit. These two combined are putting out 160 watts of power into the environment. That always has to be true. So as you're doing this problem, you can use that to check your work. Any questions? That's it.